Alright, this video is about SOHCAHTOA. Some's old, some's new, so you want to pay attention to it. What you already know are these sine, cosine, and tangent. These are called the primary identities. Basically, sine we know is a side opposite of hypotenuse. Cosine of an angle is equal to the adjacent side of hypotenuse, and tangent of an angle is equal to the ratio opposite side over adjacent. So any of those sine, cosine, tangent values are equal to some fraction. These new ones are cosecant, secant, and cotangent. Cosecant is reciprocal of sine. Secant is reciprocal of cosine. Cotangent, most people don't mix up, is reciprocal of tangent. The way I keep them straight is S starts with sine, but it doesn't start with this reciprocal. Reciprocal starts with C. Also, C begins cosine, but C does not begin with reciprocal cosine. Reciprocal cosine begins with S. So not only are they flipped, I just see the letters are kind of flipped too. Like the letter starts with S and it flips to C, and cosine starts with C and flips to S. So anyway, when I heard it that way, it made sense to me. But basically, you know this. Cosecant of an angle is equal to side hypotenuse over the opposite side. Secant of an angle is equal to hypotenuse over adjacent side. And cotangent of an angle is equal to adjacent side over hypotenuse. So if you these are called the secondary identities. Secondary identities. And if there's anything there that's new that you didn't already know, I'll write that down because this is one of those things you need to know. Saying that's pre-calculus is primarily trigonometry. All right, I'm about to erase the screen though. Okay, so in this example it says find the ratio for sine, cosine, tangent, cotangent, cosecant, and secant for the angle theta. And here's theta inside this picture here. So you want to find sine, cosine, or all 6 trig functions for that angle. So basically let's start off by first finding the first 3. Sine of angle theta. Sine is equal to side opposite over the hypotenuse. So what's opposite of that side is, I know I was in 10th grade learning geometry. I just learned whatever opposite was, it was the one that didn't make the side. So both of these sides, make the angle. Both of these sides actually make the angle. So neither one of those could be opposite. That only leaves one side left for opposite, and that's the 5. So if you're kind of stuck on what's opposite, look for what forms the angle, and those two are both technically, by definition, are adjacent to it because they form the angle. However, this adjacent one already has a name. It's opposite named it, so we call it hypotenuse. So, and we reserve the other one to be called adjacent. So once you know that both of those are adjacent, decide which one is the hypotenuse. That leaves you with the adjacent side. So the sine of the angle has to be equal to 5 over 13. And then you can go down and you got to find cosine of the angle. Cosine of theta. And that's adjacent over hypotenuse. And if that's the case, it's going to be the adjacent side over the hypotenuse. So it should be 12 over 13. And tangent of the angle should be the opposite side over the adjacent, so 5 over 12. Basically, if you know the first 3, the other ones are reciprocals of them. So if I want to find cotangent of theta has to be the adjacent side over opposite because of reciprocal of tan. So it has to be 12 over 5. And cosecant, CSC, of the angle has to equal to the hypotenuse over opposite. So CSC is equal to, if this is 5 over 13, it's 13 over 5. And the last one would be secant of the angle, which would be hypotenuse over adjacent. So the hypotenuse is 13, adjacent is 12, or just flip this, 13 over 12. So we found the primary identities and we found the reciprocal identities. So that's what they all are. And that's how you do them. You need some more work with that? Don't worry, I'll give you some more practice on that. But assuming you recognize how to find the ratios for them, now let's actually use those ratios to find missing parts of angles and triangles and stuff. So if you need any of that, I'll copy it as a note because I'm about to erase it. All right, first example says find the length of side AB in the triangle using the given information. So here's side AB. They didn't give it a letter, so I'm going to call it X. Calling that side X. So if I want to find the length of that side, this is what they gave me. They gave me an angle here, and they gave me a side next to it. So let's try to use sine to see if we can find that side length. Let's say I said sine of the angle 17. Let's see if it involves something in a way I can solve for X. So sine of angle 17 would be the side opposite. This forms 17 degrees. This forms 17 degrees. So neither of those are opposites. Side opposite 17 degrees is X. So it's going to be side opposite X over the hypotenuse side. They didn't give a hypotenuse side a name either, so let's call it Y. So that'll be X over Y. Sine of 17 equals X over Y. I don't know X, I don't know Y. I got two unknowns in this equation. I can't solve an equation with two unknowns, so I can't do anything with that. If I created an equation with only one unknown, then we're in business. So we can't actually use that to find out X. So suppose, this is no good. Suppose I chose cosine of 17 degrees. Cosine of 17 degrees would be the side adjacent over hypotenuse. So it would be 10 over Y. That has one unknown, so I can solve this equation for Y. However, our goal is to solve X. So technically, it's not the fastest way of solving it. However, I could go ahead and solve this for Y. And once I know Y, I use the Pythagorean theorem to find X. So if you wanted to, once you got to a point where you had one unknown, you can go solve that for whatever that variable is. And then use that fact to go solve for more variables. Sometimes it's really useful to do it that way. Because I'm still teaching though, I'm going to teach you, to find the most direct way. And the most direct way would be the next one, tangent of 17 degrees. Tangent of 17 degrees would be the opposite side here, X, over the adjacent side, 10. So tan of 17 equals X over 10. In this case, I only have one unknown, X, and I only have, and that's the unknown I'm looking for. So I can solve that. So if I actually went about solving that, I would, if I was teaching this to a geometry class, I would tell you find the value of tan of 17 with your calculator. And rewrite that as a decimal to 4 decimal places. So go and do that now. Tan of 17 degrees in your calculator. Tan of 17 degrees should be 0.3057 equals X over 10. If you didn't get this, your calculator is in radians mode, not degree mode. And if you want to put it in proper mode, do a quick Google search, how to convert for radians in degree mode in whatever type of calculator that you have. And you can figure out how to correct that real quick. Anyway, so this is the decimal value for tan of 17 degrees. And I want to solve this equation for X. And again, if I was teaching this to a geometry class, I would tell them, this is a fraction. Why not make that one a fraction? And how could you make that one a fraction? Well, you put it over 1. You call it 0.3057 over 1 equals X over 10. And then you saw that, you probably go back to 5th grade and you say, hey, I think I can cross multiply. You'd be right. You can simply cross multiply, and you get 10 times this number and 1 times that number. So 10 times 0.3057 equals to X. So I guess that would be 3.057 equals X. So no, X has to be about 3.057. I can find Y if I wanted to using the Pythagorean theorem. This would be A squared, this would be B squared, this would be C squared. I can figure out what Y was. But I solved for the missing side, so that's it. Let's do another one of those. All right, here's a new one. If you think you mastered this concept, you don't have to wait for me to explain it. Pause the video, answer this one on your own, see if you get the same thing I have. If you have it, you're good to go. Again, if there's something you never really feel like you learned, let's talk about it. Again, if you think you know it, pause it now and go ahead and get ahead of us. If you guys still got questions about it, let's look at this. It says find the length of AB again. using the triangle below. So in this case, here's AB in this picture here. So this would be the side I would call X. And I know for certain that I can start setting up ratios, see if any of those ratios work. Like, I also start naming the sides. For example, I know this side AB is the hypotenuse. I know this side that's over here doesn't come together to form the angle. So it means it must be the opposite side. So I got the one that involves opposite and hypotenuse. Of the trig functions, which two involve opposite and hypotenuse? Well, sine and cosecant. We're going to use cosecant to solve things, so I'll just use sine. So I can say sine of the angle, 29 degrees, equals to opposite side, 8, over the hypotenuse, x. And you can solve that equation. All right, so if you use what we just said, you convert sine 29 degrees into a decimal. Sine 29 degrees is a 0.4848, roughly, equals to 8 over x. I'll make this a fraction, so 0.4848 over 1 equals equals 8 over x. And then cross multiply. So you wind up getting x times 0.4848 equals to 8. Because you multiply x to this number, 1 to 8. So you haven't really solved x because x has a number next to it. So you know you divide both sides by this 0.4848. So you divide this side by 0.4848 and divide the 8 by 0.4848. You get x is equal to 8 divided by 0.4848. So I'll plug it into the calculator. You get x is about 16.5. So I know this length is roughly 16.5. All right, so that's how we find out what x is using sine, cosine, tangent. And let's actually think about finding angles now. So pause the video and get that as a note. I got one last example for you. All right, so find the measure of all the angles. All of the angles is what we're finding in the triangle below. So using information. So if that's the case, I want to find the measure of angle J. So we'll call it X. Find the measure of angle K. We'll call it Y. I can just call it J and K. It doesn't really matter, but those are unknowns that we're looking for. I know this angle is 90. It's already given. So we can use sine, cosine, and tangent. Let's use sine. Let's say sine of angle X, which is angle J. And we're going to find the ratio for it. Sine of angle X would be the opposite side over the hypotenuse. So it would be 35 over 37. So if you're going to actually solve this, you need to move sine, or take the inverse of both sides. Because you don't want the sine next to x, you want the sine to go away from it. So the only way to make it go away from it, you have to take the sine inverse of the left side. And whatever you do to one side of the equation, you have to do to the other. So do sine inverse of the right side. Which is awesome, because if you take the sine inverse of sine, just know it leaves you with just x. It cancels out both of those. So it's x equals to the sine inverse of 35 over 37, which you can plug into your calculator to find the value of. So let's do that. So when I plug in the calculator, I got x to be about 71.1 degrees, if I remember correctly. Yeah, that's what it is. So this is 71.1 degrees. I can use sine, cosine, tangent to find the last one, or I can just use the fact that all this is 180. That means these two have to add to be 90. So if I take 90, subtract 71.1 from it, leaves me with 19.9. Meaning this last one's got to be 19.9 in order to add all of it be 180. So I can find all three angles that way. So if you find all three angles, we can find missing sides of triangles. That's all I have. Good luck.